We are absolutely surrounded by a nonstop flood of data, right? Everything from financial markets to social media feeds. So, how do you make smart, real time decisions when the information you're learning from is constantly changing? That's the huge challenge we're going to dive into today.
To give you a sense of the scale we're talking about, just look at this number, 18.1 million. You know what that is? That's how many text messages are sent every single minute. This relentless flood is what we call a data stream, and trying to learn from it is, well, it's like trying to catch rain in a thimble.
So, any algorithm that even tries to make sense of these streams immediately runs into four massive hurdles. First, performance. It's got to be incredibly fast with limited resources. Then, quality. Its predictions have to be accurate, otherwise, what's the point? Third, adaptability. It has to change when the data changes. And finally, availability. The model has to be ready to go at any given moment. It's a really, really tough balancing act. Now, that third challenge, adaptability, that's where things get really tricky. Because the biggest problem with data streams is that they don't sit still. They evolve, they shift, and sometimes they completely change their minds. This phenomenon actually has a name. It's called concept drift. It's basically when the very patterns your model worked so hard to learn suddenly become useless. Think of it like this. You finally mastered all the rules to a board game, but halfway through, someone secretly starts changing them on you. All your winning strategies, poof, they just stop working. And here's the thing. This drift isn't just one type of event. Sometimes it's a huge sudden shift, like a stock market crash. Other times it's a really slow, gradual transition from one thing to another. And sometimes it's an incremental change that happens over such a long period you barely notice it. A model has to be ready for all of it. Which, of course, brings us to the million-dollar question at the heart of all this research. If your data is basically a moving target, how in the world do you build a model that can actually keep up? Well, traditionally, there have been two main schools of thought for tackling this. And a great way to think about them is as two different kinds of athletes. You've got a long-distance marathoner on one side and a team of super-fast sprinters on the other. So on one side, you've got the marathoner. This model is incredibly thorough. It learns from a long, deep history of data to build this really stable and comprehensive understanding. Its big weakness? It's slow. It's not great at reacting to sudden changes. Then, on the other side, you have the sprinters. This is a whole team of simpler models. Each one is trained on just a small, recent piece of the data. They are incredibly fast, super agile, and they react instantly to the latest trends. But they can totally miss the bigger picture. So it really feels like a classic trade-off, doesn't it? You can either have the marathoner's stability or you can have the sprinter's speed, but you can't have both. But what if that was a false choice? And this is where things get really, really cool. Some researchers came up with a new algorithm called EnHAT, and the genius of it is that it's not about inventing some brand new model from scratch. It's about combining the ones we already have in an incredibly clever way. The whole thing is built on this one guiding principle, synergy. The idea that when you make two things work together, the final result can be way more powerful than just adding up their individual parts. It's that whole 1 + 1 = 3 kind of magic. Okay, so check this out. Here's the secret sauce of how the EnHAT architecture works. While that slow, steady marathoner algorithm is busy processing an older chunk of data, new data is still flooding in. This naturally creates a little gap in time, a bit of slack time. And EnHAT uses this slack time brilliantly. While the marathoner is chugging along, EnHAT quickly trains a whole team of sprinters on the newest, freshest data. Then, for every single prediction it needs to make, it holds a little competition. It tests all the models to see which one is doing the best right now, and it simply picks the winner, the most accurate model for that exact moment. So you see, it's not just about running two algorithms at the same time. It's about using the built-in weakness of one, its slowness, to create a perfect opportunity for the other. The gap left by one part is filled perfectly by the other, just like pieces in a jigsaw puzzle. It's a beautiful idea, right? But the real question is, does it actually work in practice? Well, let's take a look at the results. This chart shows the accuracy on a real-world dataset. The marathoner on its own gets about 62% accuracy. The sprinter team does better, hitting around 72%. But then look at EnHAT.
the synergistic combo. It consistently gets the highest accuracy of them all, and that's because it's dynamically picking the absolute best tool for the job every single time.
And this wasn't just some lucky fluke. Across a whole bunch of different experiments, EnHAT was the most accurate model, an incredible 88% of the time. It was constantly outperforming its own ingredients. But here's the absolute best part, the real kicker that makes this true synergy. All of that extra accuracy, that much better performance, it comes with zero additional computational cost. Because those fast sprinters are trained during the marathoner's downtime, the whole system isn't any slower. It's just smarter. It's better, not slower. So, okay, it's a really clever algorithm, but beyond that, why is this so important? What's the big picture here? The big takeaway here is that sometimes a smarter architecture is way more powerful than just a single, more complex algorithm. EnHAT gives us the best of both worlds. You get the long-term, stable knowledge of the marathoner and the fast, reflexive adaptation of the sprinters. And that provides a fantastic blueprint for anyone building models that deal with real-time data, whether it's for spotting credit card fraud, optimizing ads, or predicting traffic jams.
And that leaves us with a really fascinating final thought to chew on. This breakthrough didn't come from inventing something brand new from scratch. It came from combining existing tools in a totally new and synergistic way. It really makes you wonder, where else are we overlooking major breakthroughs, just waiting for us to fit the right puzzle pieces together?